Yes, so now I'm excited to bring in our speakers for today's session. That's Shagun and Akshay. Hey
Hi
Shagun, hey
everyone.
Akshay, how you all doing?
Hey, hi
Hello,
Parth.
Parth.
Hi to everyone. We are doing well. What about you?
I am good. I'm in my hometown. Hey folks, put it in a comment saying that from where you all are joining us today from. Akshay, you are
Oh,
also joining us from
yeah.
Bangalore.
Yes, Parth, we are joining from the Bangalore Funds office and
Oh
very
wow,
excited
that's
to be
great.
here. Yeah,
Oh,
Hey, hi Ram.
monsoons of Bangalore are like always mesmerizing.
literally. And it's
Indeed, no
currently
doubt.
raining here, so yeah.
And right now it's a perfect time for a espresso with tech espresso.
Yes.
That's
Okay,
great.
so
That's
Ram
great.
says
Cool.
he's from Hyderabad. Good.
Yeah. We have people
Hey,
from
So
Chennai as well.
Shagun
hi, good
and Akshay,
pleasure.
Yeah,
let's start with the event.
Definitely.
Uh,
sure.
yep, yep.
Yeah. So, okay, I'll go ahead and start. Hey, hi everyone. I am
Before,
Shagun
hey,
and
sorry,
yeah,
sorry to bring in
go
then.
ahead.
Before we start, can you both give you a quick introduction to our audience?
Yeah, definitely. So I was going to do that, and yeah, I'm an Azure DevOps engineer. I basically deal with technologies like Azure DevOps, Kubernetes, and all the Azure services. So my basically work deals with dealing with customers, troubleshooting issues, and working on scripting and all. So it's kind of a hobby. It's kind of my curiosity to work on these kind of services, and yeah, here we are sharing our knowledge and brainstorming together today. And yeah, passing on to you, Akshay.
Thank you, Shagun. Hi, everyone. I'm a software engineer at Microsoft with the Azure Migrate team. I work on Movere, change tracking, and business case. Right. And I was an Azure DevOps engineer before, then I moved to a software engineer role. So I've, gone through all these things, Azure DevOps, AKS, scripting, other stuffs. So yeah, very excited to be here. Let's learn together.
Yep,
Okay.
yep. So,
So we are
folks,
good to
floor is all
start?
yours. So, Shagun, you starting first?
Yeah, Pat.
Yep. Okay, cool.
Okay. So yeah, bringing on today's topic. So automating AKS cluster creation using Bicep and Azure DevOps. So I believe that everybody know a little bit about Kubernetes services, what Bicep is all about, and Azure DevOps. And yeah, you can ping me in the comment section and say yes. So basically, I'll give a little bit brief about it. Kubernetes services is nothing but a resource that helps you managing, deploying, scaling of containerized applications, basically a container orchestration service. Jumpbox machine is basically a name of a virtual machine which we have kept. And proceeding on to Key Vault. Key Vault is basically a resource which where we will be storing secrets so that we can have a secure place where we can have our password stored. So Key Vault is a resource to store our secrets. Jumpbox machine is a virtual machine. AKS cluster is nothing but Azure Kubernetes Services, which is private. And machine outside virtual network, it's like kind of my machine. So if you see a little bit diagram, this is our basically end goal that we are kind of trying to achieve through this session. So if you see that I have a managed identity given to every resource in here, like cluster, Jumpbox machine, and Key Vault. Right. So is anyone aware about that? I have what managed identity is all about? Anyone? You can just like give me anything. Like let's make this session quite interactive, and you can ping me in the comments if anyone know about what managed identity is. So I have my identities. Managed identity is an identity that I will be assigning to Jumpbox machine. So what's the use of it? So since while deploying an application, I can't use my identity to access the resources, right? So I will be creating an identity. Um, Hi Moon Knight, something with access policies. Yeah, I won't say access policies. It's basically suppose we are deploying something. We can't say that I am using my credentials, my identity. I'm giving permissions to my, ID or identity. So I will be creating a managed identity explicitly. So this is that in Azure, you create a managed identity, which is called service principal, and we will be assigning that identity to Jumpbox machine. So my machine is itself configured with an identity. I don't have to manage it. My machine has its own identity and permissions over cluster and key vault. So if suppose secrets are stored in the key vault, so this machine can access those secrets from Key Vault if this identity has permission over Key Vault. If I give my managed identity permission over cluster, suppose cluster admin, suppose any other permission, node admin, anything, this managed identity can access that particular resource at that particular level in that resource. Suppose I just give this managed identity read permission. So at that resource, this managed identity only will have the reading permission. So this is the reason we will create one managed identity and assign that managed identity to our virtual machine. And afterwards, we will be using that managed identity to assign permissions over cluster, key vault, and other resources, dependent resources that we're going to create. Correct? Let me know if any queries, and I'll move on to my next slide. So the thing is, it's private, right? So if it's private, then we won't be having public access. Just adding on one more point. So this AKS cluster can only have access within the resources which are present in that network. If any resource, any machine which is trying to access outside that virtual network won't have access to it. So this is how we'll make a secure access so that there is no public access added to it. Moving on to my next slide. So this is basically just a screenshot of my Azure DevOps repository that will have these many bicep templates. So before proceeding ahead with bicep templates, anyone, bicep templates, what bicep is? Bicep, ARM templates, Terraform, like any resource, like any tool you are aware about, any what Terraform is. Feel free to ping, guys. Like I'm not giving any session, like we are just brainstorming together, learning together. I get to learn from you, and yeah, that's great to have a session, right? So yeah, bicep. So bicep is infrastructure as a code that we will use to deploy infrastructure. Yeah, very good. Azure Cloud Apps, Bicep is infrastructure as a code. Very correct. So ARM templates, Bicep, Terraform, these help to automate the deployment at, with cloud providers and cloud providers. So with Bicep templates, we will be using a code to deploy our resources at Azure. So here, if we see the directory structure, this is basically a screenshot of our Azure DevOps repository, AKS cluster.bicep file with a .bicep extension. This particular file will be deploying cluster and its dependencies, same jump box, key vault, nested storage SSHs, and networking. We'll cover this later. So this is basically the structure. If you see the main.bicep file, this main.bicep file will target these files, AKS cluster, Jumpbox, Key Vault, that we will be creating, and it will call it, right? So moving on to my next slide, it will give you a little bit clarification. What am I talking about? Okay, going on to my first file, Key Vault Bicep file. As the name states, Key Vault Bicep file. Okay, it will be helping us deploying the Key Vault in Azure. So the Bicep file will have these main resources. Further properties will be covered later. Just to give you a glimpse what Bicep file will contain, starting with parameters. It will have parameters. Parameters is nothing like it have a string, and the string is assigned a value. You can give any value. Suppose role name. Role name can be anything: keyboard secret user or anything, contributor, anything. Role can be anything. So it depends upon you what kind of value you want to assign to that string. So it's parameter. So how variable is different from parameter? Anyone? Wow, Ram. Yeah. A wrapper on top of JSON will deploy Azure resources, correct? That very well is suitable for Bicep. That explains it. Anyone? How variables in Bicep are different from parameters? Okay. So going ahead with variables, if you see the first variable, user assigned MSID, have resource ID, and there are some arguments passed into it. Microsoft.managed identity, user assigned identities, and user assigned MSI. So anyone, like if you know about variables, so variable is nothing like it will evaluate the expression and deployment type. Suppose I'm not passing on any static string value. I want to evaluate any expression at deployment type. I'll go ahead and make a variable. So resource ID is a function that I'll be passing on to that variable. It'll use Microsoft.managed identity, which is a resource provider, and user assigned identity is a resource type, and user assigned MSI is a parameter that I'm passing, which is the name. So what do you think it's what this function resource ID is doing? It's basically capturing fetching all the resource ID, a full resource ID of a managed identity whose provider is managed identity and resource type is user assigned identity, and I have provided the name of the specific user assigned identity I'm concerned about. Yes, on the running time, yeah. Now moving on to the third variable, role definition name. It has GUID written over there. Anyone, like what this GUID, GUID would be doing? I have passed resource ID, role definition ID, resource group dot ID to this role definition name. What this GUID function might be doing? Since resource ID is capturing the full resource of the identity, the provider, the resource type you're passing, this GUID. So this GUID is generating a unique string so that whenever a function is running, based on the arguments passed, I always get a unique value, right? So my role definition name is always unique. I don't want it to be same, right? So that's why I'm using this GUID. Moving on to my next resource, moving on to my first resource that we will be creating is assigned identity, which we were talking about in from the start. Like we will be creating one identity that we will be assigning to our virtual machine. So in this keyword bicep file, we will be creating a resource, Microsoft.managed identity, which is the provider / user assigned identity, right? The next resource is key vault. So this particular file will also create a key vault, right? Microsoft.keyvault / vaults. Next is jumpbox secrets. So next is key vault name jumpbox secrets. So secrets are something like which we will be storing in our key vault. My password, which I want to have a securely store somewhere that I can store in my key vault. So it can be anything. My admin name. Suppose I don't want someone to know my admin name as well. I can store my jumpbox admin name in my key vault. So we can generate as many as secrets you want. So resource, you can type key vault jumpbox secret, key vault jumpbox username, and then provider name / the type, resource type, right? So in vaults / secrets. So in vaults we have secrets. This is the resource type. Going ahead to the role definition. Role definition, resource role definition, Microsoft.authorization role assignment. Anyone? Easy to guess what this role assignment might be doing on this key vault. There is a parameter called role name, a key vault secret user, and I have created one resource, role definition, role assignment. Bit familiar, right? So role assignment, I have a role, I have an identity. So it explains, it's assigning key vault secret user, the role name, the role to that specific identity, right? So we are assigning that key vault secret user permission, access to that identity, so that that particular identity has access to read the secrets that I will be storing in my key vault. As simple as that. I hope we are good to proceed ahead, and it was basically very simple, right? Okay, moving on to my next slide and next file, that is networking bicep file. Very well. Okay, so yeah, starting with parameters, use as many parameters as you want to. It depends upon your convenience, what parameters you want to add and what name you want to assign to your parameters. The first resource in the networking bicep file, virtual networks. The main and the important one, virtual networks. Anyone, like you see, right? Let me ask one question. What do you think? If I have a resource in the same virtual network but different subnets, will they communicate with each other? The resources have different subnets. Will they able to communicate with each other in the same VNet but different subnets? What you guys think? Any opinion? Any suggestions? Any answers? Okay, I'll be waiting for your answers and see. In my virtual network, I am yes by default. Yeah, Ram. Very true. They'll be able to communicate with each other. Afsal, by default, yes. Very well. Everybody knows that. Correct? Yeah, that's really cool. Peering is required when we have two different virtual networks. So if I have a resources VNet 1, if I have another resources in VNet 2, so I need to have a VNet peering to enable communication. But if I have one VNet and this VNet has multiple subnets in it, then the resource can communicate with each other. So simply, if the resources are present in same virtual network, they will be communicating with each other, right? So in my virtual network, I'll be creating three subnets: AKS subnet, which very well states it is for AKS; Jumpbox subnet, which states it's for Jumpbox machine, virtual machine, where I log in and will be accessing the AKS. And the third is Azure Bastion subnet. Anyone, Azure Bastion subnet. What Azure Bastion is? Something new, right? Azure Bastion. And if you see in further resources, we are creating one public IP and a bastion host. What this bastion is? What's the use of this bastion? Anyone? Okay, very well. I'll go ahead. So Azure Bastion secure way to SSH. Tharuka. Ah, very well, very well. You all know about it. Yeah. Very correct. It's a secure way to access our virtual machine. Since we are creating a private AKS cluster, a secure way to access our AKS, VM, a secure environment, this is basically a secure way to SSH. So basically, using public key or key from keyword, you can SSH host. Okay. So it's basically you can treat it like a intermediary which will act between your Jumpbox machine, so that whenever you're trying to connect your virtual machine, all the traffic you are not hitting directly to your virtual machine, it is going through Azure Bastion. So any traffic that will try to go to the Jumpbox machine will pass on through Azure Bastion. Azure Bastion will have the public IP, and we will Azure Bastion through that into that public IP and perform the functions. So we are not directly accessing our virtual machine. So it's a secure way basically to access our Jumpbox machine. Right? Okay, so moving on to my next slide. Jumpbox bicep file. Jumpbox. It's nothing, just a virtual machine. So I must say virtual machine bicep file, right? So if you see in my first parameter, there is a @secure I have written. So it states that my admin password is a secure value. I don't want my logs to uh, show my password. So I want it as a secure string. That's why I have added in bicep. If you want to secure, we add it as @secure closure brackets, right? I'll proceed on. And parameters, then we have variables, right? We discussed what variables are. Then we have resources. First resource is public IP. As a VM, it needs public IP, network interface, NSGs. We will be creating a virtual machine as this bicep file states, Jumpbox bicep file, and a custom script. So my first question is, what NSG is? Anyone? NSG. There is a resource, Network Security Group. The provider is Microsoft.network, and we have network security groups. Why we need these network security groups? NSG rules, you might have heard about it, right? That check your NSG rules if you're not able to access the virtual machine. What about these NSG rules? Somehow related to traffic, right? So this NSG basically controls the inbound and outbound traffic. So yeah, if you want to open any ports, if you want to deny any inbound traffic, if you want to deny any outbound, allow anything you want as per your convenience, you can use this NSG rules to control the flow of the traffic to your virtual machines. Very good. Yeah, that's true. Inbound, outbound traffic. That's great. It's really fun to brainstorm together. Thank you so much for your comments, guys. Okay, so the last resource, if you see, is the custom script. Microsoft.compute virtual machine extensions. I'm running a PowerShell custom script in my machine. Anybody, why I'm doing this? So just to give you brief, this custom script is to download my, you know, Azure CLI, my kubectl, so that I can run, kubectl commands, so that my machine is prepared to run my kubectl commands and az commands that I want to run. So it's just a custom script that will be downloading those modules and preparing my environment, right? So with this virtual machines and extensions, we can run any custom script that we want to. Moving on to next slide, AKS cluster bicep file. Everybody can guess now. Parameters, variables, so easy to create a bicep file. Define a parameters, it has variables. And now AKS cluster. So of course, I'm going to deploy AKS cluster resource. So the provider is Microsoft.container service and the resource type is managed clusters. If you see at the rate 2022.-08-03, it's basically nothing. It's an API version if anybody has any doubt on it. So also, the another resource is Azure Kubernetes Service cluster admin role assignment, Microsoft authorization role assignment. Again, we are creating an AKS cluster and using this role assignment to do what? Yeah, assigning a role to our managed identity. So the managed identity we have assigned to the virtual machine is able to access this AKS, right? So we are making it, as the name suggests, AKS service, AKS cluster admin, right? So it's basically admin at cluster level, right? And yeah, moving on to the main.bicep file. What is main bicep file? So we have talked about so many different bicep files. So how are we going to call these files? Are we going to explicitly like call one by one? No, that doesn't seem like a good option, right? So we will create one main bicep file where we will be calling the other files we have created. So simple, the funda is to have a module, networking, and the path of that bicep file, right? And the further properties and everything, the body will be discussed further and explained later by Akshay. And I think everybody is a little bit clear, like what we are going to do and how these bicep files are defined. And it's so easy. Like it's kind of instead of deploying any resource from the UI, we are using a code to automate the deployment. So I don't have to go every time to the UI, click and deploy. I have a code. I can use Azure DevOps to deploy, and yeah, it's so easy and automated way. Moving on to you, Akshay. Hey, Akshay, are you there?
Yes, yes. Thank you, Shagun. That was a pretty good introduction. Okay, guys, let me share my screen and let's get cracking. Awesome. I think you're able to see my screen now. Right, cool. Okay, so Shagun talked about the various resources that we are going to deploy today, right? The key vault, the jump boxes. So how are those defined in Bicep, right? So we have multiple templates under deploy folder, right? We have the AKS cluster, we have the jump box file, we have the key vault file, the networking file, and the main.bicep. We'll talk about it later. Let's go to key vault.bicep first, right? So how many of you know about ARM templates? Or have you written any ARM template, used it for deployments? Anyone? Okay, shall I take that as a no? Yes. Okay, anyways, I don't see any comments. So yeah, cool. So what we are going to do is we are going to deploy key vault using this particular template and assign role to the managed identity. Plus, we are going to create secrets that will have our SSH key and our jump box password and the username, right? So this is basically the template. We are going to have the SKU, right? We can take it standard, we can take it premium, right? We have the enabled for deployment, which is true, right? Because we want other resources to access key vault so that we can use it for deployment. Disk encryption false. This is the basic template that you'll have, right? We need it for template deployment so that our ARM template or the Bicep template can access the secrets from the key vault, right? We need RBAC authorization. So we are not going with access policies here. We are going with the RBAC authorization, right? After that, we have the roles. I've just written them here, right? We can give them administrator role, certificates officer, crypto officer, and other roles. Fetch the secrets from the AKS clusters, right? We have some parameters here. We have the script name. I'll show you what we are using the script for, right? We have the secret name for our SSH public key. We have the jump box password, which is getting created automatically here, right? It will create a unique string with the resource group ID 2023 and concatenate it with P and VM exclamation mark, right? We have the role ID mapping. So everything, right, in Azure has a GUID, has a resource ID, right? And so these are the IDs for the roles. We have the key vault admin role, which is mapped to this particular ID. We have the other roles as well, right? And I think Shagun, pretty much covered the variables part that we have, right? We're going to fetch the resource ID of the user assigned MSI. We have the role definition ID and the role definition name, right? So this particular small template here, 3 lines code, it's going to create our user assigned identity with this name and the location. The name will come from the parameters file or we can define it here, right? After that, we are creating the key vault in this particular step, right? Using all the parameters that we defined before and placing it here, right? Then we have this queue, the family name, the network. We are going to allow it. So we are going to allow the access from anywhere, and basically Azure services can access it as well, right? Then we are creating some secrets here, right? We are going to create the jump box secret, basically our VM password, right? That we are taking from here. It's creating automatically, right? We are going to store it in our secrets. We're going to store the username, and here, what we are doing here is we are basically assigning the key vault secrets user role to our MSI, right? And here it's not just the key vault role, we are also assigning the contributor role. I'll tell you why we are assigning the contributor role on the subscription level, on the resource group level, sorry, to our MSI, because we have a deployment script that will be running to create an SSH key on the fly so that we don't have to pass our SSH key here. What it will do is it basically a deployment script kind of creates a container instance, an Azure container instance, right? It basically spins that up in your resource group, creates the SSH key, and once its task is done, it just gets clean up, right? You
Hey,
won't see the Azure
Akshay,
container.
sorry to come in between. Can we bit like zoom in on the screen?
It's uh, okay. Just a minute. Too much. Better now?
Yep. Looks good,
Okay.
Shagun. You're on mute.
Yeah. Yeah, it looks good. If you can zoom a little bit more, actually, it will be really beneficial. Yeah, it's fine.
Okay.
It works actually. Yeah, we can
Is it
proceed
good
ahead.
now?
Yeah. Yeah.
Okay. Okay. Cool. So, okay. Here we are creating the SSH key and we are putting it in the output path of our AZ CLI so that what we can do is we can, you know, basically use the nested store SSH keys to kind of store that particular public key into our secrets, right? Into the key vault. So this particular bicep file is calling in the template, in the module, which is the nested store SSH keys. And here what we are doing is basically just storing the public key into our secrets, right? Cool. After that, we are assigning some address prefix here. We have the AKS subnet address prefix, right? Okay. And we are just defining some parameters that we'll be using later on. Right here, we are defining an NSG, which is an empty NSG as of now. Right, we can have security rules here. We have the VNet, right? VNet here with three subnets, the AKS subnet for the AKS cluster. We have the Azure Bastion subnet for the Bastion host, and we have the Jumpbox subnet for our Jumpbox VM, right? And we have given them their own address prefix as well. If you'll see, we have the 16.2 for the Bastion, 16.3 for our Jumpbox, and for the AKS, it's coming from here, the 16.16 range. Okay, we don't have any peerings as of now. And the address space for that particular VNet is coming again from the parameter, which is this, right? Next, we are creating the Bastion public IP and the Bastion host, which I think Shagun explained. Bastion host will kind of act as a intermediate between our AKS cluster and the VM outside. So it will act as a single point of entry, right? Which will make it even more secure, right? After that, we just have the scale units that we have already defined over here, right? We have all those in the parameters file. I'll take you through that as well, where we have defined everything. Right, let's go through the Jumpbox file quickly. And in the Jumpbox, it's basically just a VM template, right? What we are doing here is creating a public IP for it, which we won't be using anyways, right? Because we are using Bicep for it. And we are creating a network interface, which we have the NSG again for the Jumpbox, specific Jumpbox, and the VM template file here. Okay, so we have an identity section here, right, in our VMs. Can anyone tell me why are we attaching this MSI here, a user assigned identity here? Why do we have it? Anyone? Okay, I don't see any replies. Cool. So we are attaching our managed identity to the Jumpbox VM so that we can use it to connect to the AKS cluster or the key vault without logging in through our credentials, right? Let's go. We have the hardware profile, the the storage profile, right? We have the image. Yes, Ram, you are correct. We are using it, in the jump box to communicate with AKS. Correct. Okay, we have the network profile. We are giving it the network interface ID that we created before, right? We have the OS profile, which contains the username, the password, right? We are giving it that, which we have stored in our key vault, right? And then, we have the beat diagnostics and then other things enabled, right? Okay, so Shagun was talking about the custom script. Let's see what this is doing, right? So a custom script extension can be used to run a script on your VM, right? We can use a PowerShell script or a bash script, right, that we can run. What we are using this particular file, script here is to install Chocolatey, is to install the kubectl or the Kubernetes CLI that we call it, to install Helm and the AZ CLI, right? Because we need all these things in our VM if we want to communicate to AKS cluster, right? We need AZ CLI to log in, kubectl to run our kubectl commands, Helm for deployments, and Chocolatey to install all the other stuffs that we have, right? Let's go to our AKS cluster real quick. So this is a pretty big file, right? Let me cover it in a short time. We have the parameters defined like our cluster SKU name, the AKS version that we want, right? The disk size, network policy. We have the two network, plugins available, Azure and KubeNet. We'll use the Azure plugin as we're deploying an AKS cluster, right? We have the Azure policies enabled, disabled here, right? And we have the secure parameters for our SSH key and the AKS cluster admin username, right? What we use the SSH public key and the username for is to SSH into our node pools. Suppose, our node pool goes down or a pod is not running fine, right? We can use this particular SSH key to SSH into our nodes and, basically troubleshoot on the networking and other stuffs in our nodes, right? Apart from that, we are fetching the cluster ID. We have the subnet IDs, and we have an AKS cluster node resource group. What this does is whenever you deploy an AKS cluster, it deploys everything other than the cluster into a separate resource group where we have the node pools, the secret drivers, the load balancers, your Kube API server, and other stuffs, right? Here we have the AKS cluster template, right? We have also attaching an MSI to it. MSI is nothing, it's just a managed identity, right? A user assigned managed identities. We have two types, system assigned and user assigned. We'll be using a user assigned identity, right? We have the AKS version, and here we have the agent pool profiles. So agent pool is your node pool, right? That will have the nodes. We are keeping it to 3. We have, sorry, we have the agent pool that is created by default actually in AKS, and we have the AKS pool, which we are creating it ourselves, right? And we have the OS type as Linux, and we are using Ubuntu for it, right? In the service profile, principal profile, we are using MSI for it. And this is the main part where we are attaching our SSH public key and the username, right? The username is coming from the parameters, and the public key is, getting fetched from the key vault. And we have some add-on profiles that if we want to use it. Then we have the node resource group that we already defined. We have the network profile, right? Auto upgrade, just the node image, right? Not the entire cluster. Don't auto upgrade the entire cluster, just the node image here that we have set. And the one that we are talking about, the private cluster, right? So that we don't have access from outside, but only from resources from the same VNet. And we have some other things defined here. And this is the role assignment part where we are, assigning the Kubernetes service cluster admin role to our MSI so that it can perform the operations, right? Let's go to our main.bicep, which have all the parameters from different files, and it's calling other files, right? It's calling the networking file, then it's calling Jumpbox file. Jumpbox depends on networking because we need a VNet already created. And then our AKS cluster, which also depends on networking, right? We have the main.parameters file here where we have everything defined, right? A subscription ID, the resource group name, location, MSI name, and other parameters, right? And this is the place where we define where to fetch the SSH public key from, right? I can hear some noises. Yes, Shagun, do you have anything?
So I see that you just said that NSGs, you haven't defined any rules. So by default, like to you and to all our joinees here, what do you think by default, what are these rules doing? Allowing all the traffic or denying all the traffic, inbound, outbound? Any answers? I created an NSG and by default, is it allowing all the traffic, inbound, outbound, or denying it?
Denying.
Okay.
Taruka said
Wow.
denying. Anyone else?
Mhm. Any else votes here? Denying? Okay. Mhm. Okay. Over
Okay.
to you, Akshay, then. What do you think and what
Yes,
you know about
Taruka,
it?
it will deny all the traffic, right? Yes. Cool. Awesome. Rishabh, yes, it will deny it. Okay. So that's about the bicep files. Let's see, real quick, how do we define a pipeline for it to be automated? Just give me a minute. I'll share my other window for it. Okay. Are you able to see it? Perfect. Okay. So this is the Azure DevOps pipeline that we are going to use, right? We are creating a YAML pipeline, right? We have created a trigger that is set to none. We have the pool. We'll be using the Ubuntu latest image. And we have the jobs here, right? The bicep deploy job that will do our job, automated. So we have the settings, right, for this particular task. So if you will see the task, right, we are using an ARM managed Azure Resource Manager connection, right, an ARM service connection, right? We have it by the name of Reactor. I'll show you how do we create a service connection in a minute. We are using a shell script, right? We are using an inline script for our inline script we have defined here. So what it's doing is it's logging in through the service principal identity, right? It's ID key and tenant ID, right? We are creating a resource group which we have defined in our variables so that it can be automated. We can have a different resource group every time, right? Let's not hard code it. And then we are deploying our key vault first and note the other resources. Can anyone tell me why? Why do we need a key vault to be present? Or why are we deploying it first? Anyone? Any guesses? Shagun, do you want to take a guess? Why are we deploying a key vault first and
Waiting
not?
for the answers before exposing it. So I think everybody knows that what Key Vault is and what it stores. So why we need
So
it.
what are we storing here? Can anyone tell me? We are storing something, right, in key vault?
So the name suggests keys, vault, secrets first, capture secrets first.
Yes. Awesome. Awesome. Yes. So we are storing the secrets first here, right? So that we can refer it later on in our jump box as well as the AKS cluster, right? If we deploy the AKS cluster first, what will happen? It will fail because it's not able to find the key vault. Forget about the secrets, but not even the key vault, right? So we are deploying our key vault first. Okay, once our key vault is done, we are going ahead with the inline script that is going to deploy all the resources that we have defined in the main.bicep file, right? We have the main.bicep file that's calling in the network, the Gembox, and the AKS cluster, right? Let me give it to Shagun now to show you how, after deploying it works.
I
So we
have
are not going to deploy it
just a
here.
question
Yes,
here.
Shagun. Hmm.
So I see you have used a
Yes.
command az deployment group create and the name of a
Mm-hmm.
resource group, the template file as main bicep and parameter file, right? So this main bicep
Yes.
file is referring to the parameter file. So why is it
Yes.
az deployment group create? A group, right? What is the significance of this group? Anyone? What else can be here if not group? Az deployment group create. There is one more command called az deployment sub create. So anyone, how it differs? This is az deployment group from group, something clicks from sub, subscription, resource groups. hmm Over to you, Akshay, if you can
Yes,
just give the
Ram.
brief about it.
Yeah. I think Ram already answered it, to deploy resources at the resource group
Yeah.
level, right? That's why we are passing in the resource group here, right? So that we can deploy our resources, whatever we have in our main.bicep, to this particular resource group, right? Awesome. Over to you, Shagun.
Thank you so much, Akshay, for the deep intro into the long, lengthy files. So, yeah, very well. I will quickly share my screen to. So, the thing is, once this pipeline is executed, I'll show you what resources it deploys and what we get to see. Right, and here I go.
I think you're sharing the wrong screen, Shagun.
Okay, is it? A moment.
Yeah.
Is my screen visible?
Eh, we can see your main.bicep, Azure DevOps. Can you go
Okay,
to the
okay,
resource
okay.
groups?
Yeah, sure. Okay, I'll go to the resource groups. What I did, I just typed here resource groups in my Azure portal. I went to resource group, and since the name of the resource started from Reactor RG, I typed here. So if firstly I'll go to my second resource, Reactor RG, which is the main one where I deployed all of my resources. So if you see, Kubernetes services. We talked about we deployed AKS service, so we have Kubernetes service Bastion. We talked about we are deploying Bastion host, public IPs, virtual machine. Virtual machine is here, jump box, right? NSGs, public IP, key vault, managed identity. Here is it our managed identity, virtual network, NSGs, and the deployment script. So moving ahead. Um, Let me try one thing. Let me ask you one question. Just a moment. Let me ask one question. I'll try to access this particular Kubernetes service through my machine. Anybody, what will happen? I'll quickly share my screen as well, and meanwhile, waiting for the answers. So I hope my screen is visible. Okay, so
Yes.
I am going to my Kubernetes resource. Okay, I'll try to access my private cluster, right? Now let's see what happens. I click on connect. I have my commands over here, so I don't have to do the overhead of executing my commands. I'll paste my command and it's taking a bit time. Sorry. Okay, I did my get credentials. Okay. Merged. Unable to connect to the server. Anyone, why this happened? Right? Because it's our private and we have given a secure access to our AKS. So this was an expected behavior that we are denying a public access to our AKS, right? So, okay, now let's see what Bastion host we were talking about, what actually it is. For that, I will go to my virtual machine. This is the Jumpbox machine we were talking about. The name is very cool, right? Jumpbox. Okay. I click on connect. So if you see, in this particular Jumpbox machine, I haven't given it any traffic flow or any ports. I haven't opened anything. I'll just connect it through the Azure Bastion. I'll go to Bastion and I have my password. Where is my password? So I will go to my key vault. This is my key vault, the secrets, and oh, anyone, I am getting your unauthorized to view these contents. Let me check my access. View my access, please. I am the owner of this key vault, but why I am unable to still see these secrets? What permission am I lagging? I remember that if anybody remembers that I used that particular role name in my slide, if anyone catched that, that is required. But I am the owner of this resource. If owner is not having access to his house, then who will have it? What particular access am I missing to get into my house? I'm the owner of house, but I need some access to get into house. What kind of access I'm lagging? Anyone? I talked about this role name, key vault, something something. I need to, have access to the secrets. So let's go back to the access control. I'll go to the roles, and if you see, there is one role called Key Vault Secret User. Until and unless I don't have this role, how can I use that? So I'll go ahead, add a role assignment, which I provided to the managed identity through Bicep. Search for that role. Key Vault, where is it? Where is it? Yes. I'll go next. I'll go ahead, select me as member, select it, and review plus assign. Okay, it's giving me the access. Let's wait. Go to secrets. Still, let's refresh. Uh-oh. Hey, we got it. So we created 3 secrets: AKS Linux profile SSH public key, Jumpbox admin, Jumpbox password. So if I go back to my Bastion host, it requires a username. So of course, I'll use my Jumpbox admin. So I'll go over here and I can see my secret value from here. If you want to anytime see it or just hide it, just copy it. It will copy it for you, right? And I'll use my username since it's not an important entity, like it's not very sensitive entity, though being just to have a secure access, I'm storing it in the key vault. So VM password. I don't want to manually type my password. What should I do? So it has 2 options: VM password, manually type it, or password from Azure Key Vault. So I'll select the key vault where my secret is stored. I'll select my key vault and the name of the secret, Jumpbox password. Voila. We have it. Now I'll click on connect. Let's see whether it connects us or no. Okay, connecting. Okay, it connected us. It seems like yes, it connected us. So yeah, I'll execute the same commands that I used in my machine to access my Kubernetes. What do you think? Now, this dumbbox machine will be accessing it or no?
I
Since
don't
this
think
is
so.
a jump box, I'll first do my AZ login because I have to perform AZ login. And since my machine has an identity, I'll use an identity option. You guys remember, right? We created a managed identity and assigned that identity to Jumpbox machine. So if I use this command, az login hyphen hyphen identity, it will use that identity of it to log in into Azure. So if I click on it, what will happen? It should log in me to the Azure, right? It should authenticate and authorize me. Okay, I got an error. No access was configured for the VM. That's strange. Let's check our VM actually. Why this is throwing this error? Okay, I'll go to my resource groups just to be little simple. My reactor RG resource group. I'll go to my Jumpbox machine. I'll check why this identity is not, giving me access to login into Azure. Oh, I see the system assigned identity is on. And what identity we created is user assigned identity. So I have two identities now. How will system know that what identity to use? Confusing, right? Either you can just turn off the system assigned identity, or what we can do is I'll go to my identity that I created and I'll use this client ID, which is the ID, and I'll try using this command now. Logged in. See, now the system knows which identity to use. It helped me to log in into Azure. This was the basic benefit of this creating this managed identity. So he saw, right? We had a managed identity, Reactor MI, right? So we did it, and now I'll use the same commands. Easy AKS get credentials. Let's see if it executes. Okay, it fetched the credentials, and now, okay, I'll just to kubectl get nodes, the default namespace itself. Okay, voila. I'm able to access my AKS. So if I quickly share my screen to my, just a moment. Um, this particular little diagram, if anybody is able to see. Is it visible? Okay.
Yes.
So this was my machine outside network. When it tried to access, got responses, no, I won't give you access, right? If you saw that. And now when I accessed from the Jumpbox machine, it was successfully giving me the results. So this is how it worked. I have a secure access to my private AKS cluster. So one more thing I would like to ask you guys. You see, right here, one more resource group got created, and Akshay talked about this resource group. Anybody remember about this resource group? And it has some AKS pools, agent pools. I think this is similar to this result. AKS agent pool. Oops, so sorry. AKS agent pool and these VMSs. Oh, I have these. I have Cube API servers. I have load balancers. Something related to AKS. Akshay, do you want to anything why this resource group got created?
Sure, Shagun. I think you're sharing the wrong screen. We are still able to see the PowerPoint presentation, not the resource
Okay,
group.
so sorry for that. Yeah, just a moment. Let me share it. Okay. Here I go. So just repeating
Okay.
that factor, I got created two resource groups here. This
Mm-hmm.
particular resource group, Reactor AKS cluster resource group, has added like these AKS agent pools, managed identity, load balancer, private Kube API server. What? Why this resource group got created? Because I created only one, Reactor Archie. Anyone? Akshay, over to you. Help, please.
Let's wait for the answers. I think we are a bit over time, but yeah.
Mm-hmm.
Okay, so let me take it. So whenever you create an AKS cluster, it creates you a separate resource group for all your nodes, right? Wherever, so AKS doesn't store its resources there. It stores the dependent resources in a different resource group, which we call as the node resource group, right? So you'll see the Kube API server and other stuffs in this particular resource group. And as soon as you delete your AKS cluster, you don't need to come here and delete all these resources manually. AKS cluster knows where its dependent resources are. It will just delete all of them. So yes, that's the thing.
Okay. Really insightful. Thank you so much, Akshay, for answering it. So, yeah,
Yeah.
I think we're all done. We have automated our deployment. AKS cluster is there. We are able to access it through Jumpbox machine. And yeah, so Ram has a question. Does Azure creates it?
Yes, Ram. AKS creates it.
Okay, we're
Any
good.
other questions?
Feel free to ping any of your queries. We are open for our questions. And thank you so much for joining. It was really fun brainstorming together, and I hope it was same for you guys. Thank you so much, Ram.
Thank you, everyone.
Thank you all.
Hey everyone, thank you for a great session. Thank you so much. Final call to all the folks who all have any questions to drop in. Please drop the questions in the comment section. We all can take from there. So Afzal has a question. You want to take it up, Shagun?
Okay, so I still want to ask, can we get the bicep codes to try into their labs? Yeah, surely we
Sure,
can share a
Afzal.
GitHub link for that soon.
We can paste it in the comments later on because right now it's a private repo, right? We can make it public in our GitHub repo and share it.
Okay.
Yes, Rishabh will share you the link once you post it into GitHub. It's in Azure DevOps private repo as of now.
Okay.
I think
Cool,
there are no
folks.
other questions. Yep.
Mm-hmm. Yeah.
Yep. So yes, I have also shared the links for the intro to Kubernetes and fundamentals of biceps, and there is also an intro link for Azure DevOps that I'll be
Azure
sharing now.
DevOps.
Yes.
Thank you, Afzal.
So these are the links which can take your learning further. And thank you so much for being today at the show. And thank you, Shagun and Akshay. Thank you so much.
Thank
Thank
you
you,
so